Okay, we're on the last page of the review. We're going to look at 26A and B. Now, these are not quadratic equations. One of them goes to the third power, one to the fourth, but both of these can be solved by factoring. So we're going to start by putting everything in standard form, which means equal to 0. I'm going to pull this x squared over. I want it in the middle, so I'm in descending order. And remember, when I change sides, I change signs. Okay, so once I get to here, I'm noticing that everything has an x. Okay, so I can factor the x out. Now, the one I'm left with, I do have to do the factoring by grouping. So I'm thinking -6, 2 times -3, and -1. So let's see, a 2 and a 3. If I made the 3 negative and the 2 positive, that'd give me a -1. So I'm going to split that middle term into a positive 2x and a negative 3x. So I'm splitting right here. And I'm going to do my grouping. So I'm going to make this a bracket just so that we don't forget about that x, because that's important. I can take out a 2x, that leaves me x plus 1. I can take out a -3, and that also leaves me x plus 1. So I end up with x times x plus 1 times 2x minus 3. And remember, this is all equal to 0. So it's fully factored, but it's not solved. So now I need to set each factor equal to 0. Alright, so that one's solved. This one I'll get x equals -1. This one I get 2x equals 3, or x equals 3/2. So I end up with 3 answers here. A 0, a -1, and a 3/2. So if you look at the biggest exponent in your problem, that's going to tell you the most solutions it can have. So I know this equation can have at most 3 solutions, and I've found all 3 of them. So if we move on to B, I want to do the same thing that I started the other problem with. I want to put it equal to 0. Now this is what we call quadratic in form. I have an x to the 4th instead of an x squared, but I can factor it like a normal trinomial, but instead of x times x, I'm going to do x squared times x squared. I still want numbers that multiply to make 36 and add or subtract in some way to make 5. So let's see, 9 and 4 would work. To get a -5, I need a -9 and a +4. Now these still have squared, so I'm going to check them again. X squared minus 9 is a difference of squares, so x plus 3, x minus 3. Now this one doesn't factor because it's a sum of squares, so I'm just going to leave it alone. And now it's fully factored, so I set each factor equal to 0. So x plus 3 equals 0, x minus 3 equals 0, x squared plus 4 equals 0. So I get a solution of -3, I get a solution of +3. Now this one, I get x squared equals -4. This is a quadratic, so what I can do is take the square root of both sides. I need a plus and a minus. And I get x equals plus or minus, and then remember the square root of -4 is 2i. So I actually have 4 answers here. I have a -3, a +3, a -2i, and a +2i. So if we go back up to the original problem, oh, there it is. Notice my biggest exponent is a 4, so I know it has at most 4 solutions. Alright, so the last one I want to do in this video, this one is also quadratic in form, but it's a little strange looking. I do want to think of my x to 1, oops, let me erase that. I want to think of my x to the 1/2 as the square root of x. If you remember that back from chapter 1. And this one's a little odd, but I'm going to try to factor it with my FOIL backwards. So normally we do x times x to get x squared. So what I'm going to do this time is I'm going to make both of these square root of x. So remember, square root of x times square root of x, it's just going to give me x. So that would work if I fooled that out. Now I want numbers that multiply to make 10 and add or subtract in some way to make 3. So 2 and 5. I want the 3 to be positive, so I do a positive 5 and a negative 2. So that's a really unusual way to factor, but it does factor. If I FOIL it out, I'll get the same thing back. So now I can set each factor equal to 0 and solve. So I get the square root of x equals 2, and over here the square root of x equals negative 5. Now I'm not solving for square root of x, I'm solving for x. So to get rid of a square root, I square both sides, and I'm going to do this for both equations. So I get x equals 4 and x equals positive 25. Now remember, if you square both sides of an equation, sometimes you get extraneous roots. So in this case, I have to check my answers. I don't have an option, I do have to check them. So I'm going to do my check down here. So let's start with x equals 4. So I'm going to go back up to this equation right here, and everywhere I have an x, I'm going to put a 4. So this is going to become, just kidding, let me switch back to my pen. So in place of this x, I'm putting a 4. In place of this x, I'm putting a 4. And I want to see if this is true. So I know that the square root of 4 is 2. So I end up with 4 plus 6 minus 10 equals 0. Well, 4 plus 6 is 10. 10 minus 10 is 0. So that checks out. That means I get to keep this solution. So let's try the same thing with 25. I'm going to go back, and everywhere I have an x, I'm going to put a 25. Excuse me. So 25 plus 3 square roots of 25 minus 10 equals 0. That'll be 25 plus 3 times 5 when I take the square root, and I end up with 25 plus 15 minus 10 equals 0. Well, that actually comes out to be 30 equals 0, which does not work. And you might notice a problem right here. Before we squared it, we had the square root of x equals negative 5. It's impossible to have a square root equal to a negative, so we had a little bit of a problem there. So that one was an extraneous root. We throw it out, and we keep our one answer of x equals 4.